All right, welcome. In this video, we will be going through 9.1. Now, this may be a little bit of a review for you. You might already have some of these problems done in your workbook, but I would encourage you to follow along. Pause the video at any point in time, back it up, watch it again on those questions that you're struggling with a little bit that you maybe want to hear a second time. Also, pausing it allows you to make sure that you can keep up with the video, as some of these I will be going through at a little bit of a quicker pace. So we are on page 37. I'm going to zoom in here in just a moment. And in this video, I'm going to go through all of 9.1, which is going to take us up to question 57, but I'm only going to do those highlighted questions. So here we go. We begin just with the idea of a square root. So the square root of 49 is just what number times itself gives us 49. This can be done through just mental math, or it can be done through the use of a calculator. It's important that we know where the square root button is on our calculator. So here we go. The square root of 49 is just 7. When we look at number 2, we're taking the square root of negative 4. The square root of negative 4, what number times itself gives you a negative 4? Well, the fact that a negative times a negative gives you a positive, and a positive times a positive gives you a positive, there is no way to multiply a number times itself and get a result of a negative 4. So we say that this is not real. It could be expressed as 2i, bringing in our imaginary number. But for this course, we're going to say not real. When we look at number 3, we have a fraction. We have the square root of 81 over 25, which can be broken up into the square root of 81 over the square root of 25. The square root of 81 is 9, and the square root of 25 is 5. Number 4, we have a negative square root of 36. Now, that is different than the square root of a negative 36. These are not the same problem. This one over here would not be real. So this one keeps the negative sign, and then the square root of 36 is just 6. Number 5, most of us knew or know where the square root button is on our calculator. We may not be as familiar with the cube root button. If you push the button that says math on the left-hand side, below, I believe, the green alpha button, hit that math button, and you will find the cube root. It generally looks like that, cube root of x. So you'll take the cube root of 125, which is just what number times itself 3 times. And that is going to be 5, because 5 times 5 times 5 is 125. You might be tempted to say that number 6 is not real, because we've got a negative underneath that radical. But this is a cube root, and cube roots are different than square roots. We are allowed to have a negative under a cube root. The cube root of negative 1 is negative 1. And the reason for that is because negative 1 times negative 1 times negative 1, 1 negative times a negative gives me a positive 1, but then positive 1 times negative 1 gives me negative 1. So the cube root of negative 1 is negative 1. Let me just erase all that and give you just our answer again as negative 1. The fourth root of 81, so we're looking for what number times itself 4 times is 81, and that's 3. You're looking for that button that looks like this, or it might look something like this, and you're allowed to punch in. Sorry, that's not a 4, that's a Y. You're allowed to punch in that value for whatever root you're looking for. It's not likely that you have this button. That's not as likely. Mostly it's this Y root of X or X root of Y. All right. Skip all the way ahead to number 11 here. We've got the cube root, and I want to focus first on what's inside here. The cube root of a negative 1,000, that's negative 10. And then we bring this guy down, so now we have a double negative leading to a positive 10. All the way here to number 15. So this is the cube root of, and if I combine those, I get a negative 25. Let me just rewrite that for us here. Okay. Just pausing for just a minute here. And that's actually 27, isn't it? Hoping you caught that as I went through that. So the cube root of negative 27 is negative 3. Negative 3. 9 minus 36, negative 27, not negative 25. There we are. All right. So that's that first section. Now we're going to move on. And in this next group of problems here, 17 through 28, we're going to see a pattern that we're going to develop here in the first few problems. So we have the square root of 8 squared. We could go ahead and take that to 64, great, because 8 squared is 64. Well, and the square root of 64 is back to 8. Notice this answer here is the same value that was right here. And the reason for that is because this is a 2, and so is this. It's a square root. We don't write that 2 out there, but it's really there. And so those two values match. They're both 2s. And when that happens, we end up with, again, this number that we started with right there. And we're going to see that as we work our way through this. 18 is a little bit different, and the reason for that is because we're going to square this negative, which would take us to 36, and then back down to 6. So we don't see the exact same number there, but that's because when we take negative 6 and we square it, we get up to 36. And then when we take that square root, we're back to 6. All right. Later on, I'm going to talk more about why, a little bit more in detail about why this answer is just y. But for this group of problems, for this section, it's because these 2's cancel each other out, and we're just left with this value underneath. Again, these values cancel each other out. They're 3's instead of 2's this time, but they still just cancel each other out, leaving me with just 5. That same thing works with an expression like x plus 7, once again, and I'm writing these 2's on the radical ledge there just to really emphasize this idea of those are 2's. They cancel each other out. And so we're just left with x plus 7. All right, I think I'm jumping down to 26 now. Their 7's still just cancel each other out. D minus 8. 28, back to 3's. They cancel each other out. X minus 6. Okay. In these next 2 sets of problems, 29 through 36 and 37 through 44, we're given an f function and a g function, and we're asked to evaluate. So in 29, we're asked to evaluate f of 100. First, it's an f function, which means we're going to plug it into f of x, which is just taking the square root. So when we evaluate f of 100, we're just taking the square root of whatever value we're given. So that's the square root of 100. So f of 100 is just 10. Square root of 100 is 10. 31, g of negative 1. So now we're looking at the g function. Let me grab my arrow here. So now because this is a g, we're looking at the g of x. So we're going to take the square root of 3 times whatever value you're given plus 4. So g of negative 1 is equal to the square root of 3 times the value I'm given, negative 1, right? There's that value, plus 4. So then, let's see here, that's negative 3 plus 4, which is 1, and the square root of 1 is just 1. So g of negative 1 is equal to 1. F of a, so again, we're going to go into that f function, and that just says, hey, take the square root of whatever you're given. So the square root of a is, well, we're done. We can't do anything with that. And we're going to talk later on in this video or the next video about how we talk about or take those square roots when they're just variables, just letters. G of 2n minus 1. So we're going to take the square root of 3 times whatever I'm given plus 4. Here I'm going to go ahead and distribute. So 6n minus 3, I got that from distributing 3 times 2n and 3 times negative 1. And then I have to add that 4 still. So I'm going to combine my like terms. And I'm left with 6n plus 1. And that's all we can do. This next set of problems, same idea, but just with cube roots. So we're going to do a couple of those. So this first one's an f function, f of 64. And so f of 64 is equal to the cube root of 64, which is just 4. (39g) of negative 4. So let me slide over so I can see the g function here. It is the cube root of 4 times the value I'm given minus 1. So that is the cube root of negative 16 minus another 1, or the cube root of negative 17. Negative 17 does not have a cube root, so we would just leave it like that. 42g of 2a minus 3. So I'm going to take the cube root of 4 times 2a minus 3 minus another 1. And that is distributing 8a minus 12 minus another 1. Cube root of 8a minus 13. I should probably get my notation going over here. And finally, f of 5k minus 12 is, or minus 2, excuse me, is equal to the cube root of 5k minus 2. And that's all we can do there. Okay. So that's it for that component right there, that piece right there. Let's move on to some domain work, and I'm going to do just 3 of these. They're pretty straightforward. When we talk about the domain of a radical, our restriction here is that whatever is under the radical n plus 2 must be greater than or equal to 0. So now I solve this little inequality, subtracting 2, n must be greater than or equal to negative 2. That's one way to write it. The other way to write it says, I'm going to go from negative 2 to infinity. Bracket at negative 2 because it's greater than or equal to, and then of course parentheses at infinity. Looking at 49, whatever we have underneath that square root, 2x minus 5, must be greater than or equal to 0. Adding that 5, 2x must be greater than or equal to 5, dividing by 2, x must be greater than or equal to 5 halves, or 5 halves to infinity. Last one, we have a cube root. We can have a positive or a negative or 0 underneath a cube root, so there are no restrictions. So we could list it as negative infinity to infinity or all reals. So there are no restrictions there. This next section here we're going to graph, and I've just picked 3 of them to graph. Up at the top I've listed some key points. The key points for a square root graph are 0, 0, because the square root of 0 is 0. 1, 1, because the square root of 1 is 1. 4, 2, because the square root of 4 is 2. And 9, 3, because the square root of 9 is 3. So when we're given a square root equation to graph, I start by plotting those points. Let me blow this up here. So 0, 0, 1, 1, 4, 2, and 9, 3, 5, 6, 7, 8, 9, 1, 2, 3. All right, I'm not going to connect those. I'm not going to draw on my curve yet because now I'm going to take this and I'm going to say, well, what impact does that minus 1 have? And thinking back to Algebra 2, when it's connected to the variable like that, it's a horizontal left to right movement, and it's kind of backwards from what we would think. So we're going to slide to the right one. Grab a different color here for dramatic effect, and each of my dots is going to be slid to the right one. And there's my square root of x minus 1. 55. We're once again starting with those key points for a square root graph. 0, 0, 1, 1, 4, 2, and 9, 3. Now we're going to take this minus 2, which is going to slide the graph down to, because it's not this, it's not an x minus 2 under the radical. The minus 2 is outside of the radical, so not connected to the x. So now it's a vertical shift up or down. So down 2. And my curve. Lastly, I've identified a cube root 1 to graph, and so here we go. Cube roots. So we've got 3 of them in the middle. So we have -1, 0, 0, and 1, 1. These 3 kind of are linear through the middle. Then on the outsides, which really helps shape our cube root, we have -8, -2, and +8, +2, because the cube root of 8 is 2, and the cube root of -8 is -2. Okay, so I'm going to start by plotting those 5 points. So we've got those 3 through the middle that I talked about. -1, 1, 0, 0, and 1, 1. Now on the outsides, we have 8, 2, and -8, -2. All right, I think that's at 8. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. Sure is. Okay, now our transformation here is going to, the -2 is connected. That is connected to the x underneath the radical, so that's the left to right. So we're going to slide to the right too. All right, so this curve is going to come in relatively flat up and leave relatively flat. It's just a tipped over cubic function. Okay, so that's it for this video. I'm going to pause right here. In the next video, I'll take off with 59 and go from there.